Hi again, guys. This is the worksheet boiling point, elevation, and freezing point depression worksheet. It was a separate handout. If you did not receive this before we left, then it is also a PDF on its learning. You are not required to print this, but you can also work the problems out on notebook paper if you'd like. Just make sure you label everything and keep up with it, or you have, of course, the choice to print it out if you would like. I just cannot require you to print. So I'm going to go over our first couple problems just because the first one is over freezing and the second one is over boiling point, just to kind of show you the differences again as you practice this. So our first step is to make sure we underline our numbers. So 3.68 moles of sucrose, and then a couple other pieces of information is we want the 2.5 kilograms of water, and then remember that your freezing constant is that negative or 1.86 Celsius over molality. So first step that we're going to do is we need to calculate molality. Remember that molality is going to equal moles over kilograms. So pretty easy from lecture 5. That S looks a little weird. So we're going to type in 3.68 moles over 2.50 kilograms. Yes, they have to be in moles, and the other number has to be in kilograms, can't be grams. So make sure you do change that. And this answer should end up being 1.47 m. We're still going to the hundredths place when rounding, so 0.47. And now we're going to plug that into our change in temperature freezing formula, which is I times the constant of freezing times molality. So when we're reading the question on here, it says what will be the change in the freezing point? Okay, so it's not asking for our new temperature, it just wants to know how much we're changing. This is a two-step problem simply because for this formula we didn't have the molality, so we had to do this first step here to calculate the molality to then use this formula. So the change in temperature for freezing, our I value, we have to kind of go back and think about, well, what are we actually using? Like, what compound are we using? Okay, so when we're looking at this, for you, the I value will be 1. This one's a little funky. And then your constant is 1.86 degrees Celsius. And remember, it's negative because it's freezing, so we want to drop that negative, times 1.47 molality. And the reason that the I value is 1 here is because this is an entire compound for sucrose. It doesn't break up into ions because it's an organic compound. That's not something you're going to have to memorize. The ones that we'll have on the test or the quiz are going to be really, really simple, like in number 2 where you have sodium and fluorine and they break apart really easily. So you're not going to have to second guess yourself on that, okay? Just be careful with them in case you have questions. And if they look like really big compounds like that, just ask me. So once you do your math, then you should have triangle or change in temperature is going to equal a negative 2.73 Celsius. It's always negative when we're doing the freezing because it just means it's dropping below 0. So that's how much our temperature is going to change. It will drop below 0 by 2.73 degrees Celsius. All right, moving on to the second problem. Try to scoot that out of the way, a little less confusing. So notice this time we already have the moles, 5.76, and it's sodium fluoride. We have 3.62 kilograms of water. So again, the same issue, we need the molality. So 5.76 moles divided by 3.62 kilograms, and that is going to equal 1.59 molality. And again, you're welcome to write moles over kilograms, or you can just simply write a little m. Then for our formula, this time they are asking what will the change be in the boiling point. So it's exactly the same formula as we used in number 1, we just have a different constant. So the change in the temperature for boiling still equals the I, the constant is for boiling, so we put a B, and then our molality. So the I value here will be a 2 because you have sodium and fluorine and they both break apart into separate ions. They're not a large compound. The value for the constant is 0.512 degrees Celsius over molality, and then your molality that you calculated just a minute ago, 1.59 molality. So your triangle temperature, or your change in temperature for boiling point, will be 1.63 degrees Celsius. So pretty much exactly the same process, you're just starting again. Let me know if you have questions and I'll post the answer key later. Thank you.